this class. Now, before we go into the graphs, we understand one more quantity, which is known as acceleration. What is acceleration? Rate of change of velocity is called acceleration. So what is acceleration? Equals to change in velocity divided by time taken. Acceleration equals to v minus u over t. Remember, v minus u has a unit of meter per second. Unit for time is seconds, and acceleration will be meter per second square. Now, so acceleration is rate of change of velocity. How much velocity in unit of time? For example, if I question, a car is moving with a uniform acceleration of 2.0 meter per second square. What does this mean? Now, very simple question. A car is moving with an acceleration of 2.0 meter per second square. This is a statement, and the examiner wants to know, what does this statement actually mean? What is meant by this statement? Answer is, okay, it completely not telling you how fast an object is going. There is no information whether the car is at rest or it is moving with a speed of 100 meters per second, because no such information is given in this statement. But we know whatever the speed is, it is changing by 2 meters per second in every second. This is all we know. Some of you might think that this means car is moving very fast or very slow. No, we have no idea about that. We just know that if we let the velocity change for 1 second, it will change by 2 meters per second. It can be 0 right now, which will be exactly 2 meters per second after 1 second, and to become 4 meters per second after another second. And it can also be 10 meters per second right now, which will become 12 and then 14 or 100, 102, 104, 106. So if only acceleration is given, it is not letting you know what is the speed of the object right now. Is it fast, slow, or at rest? It is only telling you how much speed is changing in a unit amount of time. So answer will be, this means the speed of car is increasing by 2 meters per second in 1 second, or in each second. In each second. Okay. Now, we can bring the same example here as well. This one, but instead of velocity, we can make it instead of distances, we can make it velocities. So okay. Now, let's say if these are instead of distances, they are speeds. V1 in meter per second, V2 in meter per second, V3 in meter per second. And obviously, there will be some changes here as well. The first one, look, the speed of the car is changing and it is 0 right now. It becomes 2, and then speed becomes 6, and then speed becomes 12, and then speed becomes 20, and then speed becomes 30. So what is happening? Increasing speed with increasing acceleration. So speed is increasing, but it is increasing with increasing rate. Look at the second one. Speed is increasing. It becomes 0 to 6, and then 6 to 12, uniform or constant acceleration with increasing speed. And the last one is decreasing acceleration, but increasing speed. So if you pay attention, you will find in the last one, although the speed is increasing, but how much speed increases in a unit amount of time? That is decreasing. So this will be a case of increasing speed with decreasing acceleration. And now these graphs, they will be exactly same, but the quantities will be, instead of distance on y-axis, now we have meter per second. So on y-axis, we have speeds, and we can see that this is car 1, car 2, and car 3. And we can see that in the first car, we have an increasing gradient. That means it is an increasing acceleration. Note. Gradient of speed time graph is numerically equal to acceleration and this is note number 1, and 2 is Area trapped between the graph and the x-axis is sometimes termed as area under the graph. Area under the graph is numerically equal to distance traveled or distance moved. Now, how many different types of graphs can be there for speed time graph? Let's make all possible graphs. And we will be writing short description of each one. One second. Okay, we have velocity on y-axis, time on x-axis. Second possibility, third possibility. Okay. Let's see. First one is this, 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 in the fourth one, the line is a horizontal line right on time axis. Hmm. And if it is a velocity time graph, it can also be a negative graph. How will we explain this? Let's see. First one. Any idea how will you explain the motion in the first one? If it is a velocity time graph of an object moving in a straight line. Okay, I will pause the recording so you people can participate in the class. Just 1 second. Because whatever value is over here, it stays the same all along. And what about gradient? Yesterday we learned that the gradient is angle with the x-axis. And if we make an x-axis here, we can see x-axis and this line is parallel to one another. They have a zero angle between them. And tan of 0 is 0. So it means that this line, if it is perfectly horizontal or parallel to the x-axis, in this case time axis, it means there is no gradient and the quantity that is represented by the gradient is also zero. So this is how I will describe the motion of this object. The object is moving with uniform speed and with no acceleration. What about this one? What is happening to speed? What is happening to acceleration? So answer is, as I see the acceleration, which is the gradient's quantity. If I mix angles with x-axis along the curve, I will find out all of the angles are same. So that means that the angle with x-axis is staying constant. And if angle with x-axis is constant, it means the gradient is constant. So I would say speed of this object is increasing, but acceleration is constant. So although the speed is increasing, but speed is increasing at a constant rate. The change in speed is same for the same amount of time. So that means if you see a speed time graph like this, you should have this belief that this object is moving with an increasing speed and uniform acceleration. Now, what about this one? I hope you all can clearly see that there is a case of decrease in speed. So if there is a decrease in speed, it means we are dealing with negative acceleration or deceleration. There is decrease in speed. So negative acceleration, also known as deceleration. Decreasing speed with constant deceleration. Okay, now, how about this one? If the speed time graph is on the time axis, it means the time is going on, but there is no speed. There is no speed means the object is stationary, not moving, at rest, stopped. So, and any of these words can explain what is happening to this object. What about this one? Who will explain this? What is happening to speed? Speed is clearly increasing, as we can see that the graph is going up. But what is happening to gradient and what will be happening to acceleration? So speed is increasing, object accelerates, but acceleration is decreasing. Acceleration is decreasing. अच्छा जी. For the last one, speed is increasing. Object accelerates, but acceleration is, I hope you can see that the angle with the x-axis is increasing as we go from left to right. So graph is having an increasing acceleration because the gradient is increasing. Object accelerates, but acceleration is not uniform, it is increasing. So this one, we can see that there is a decrease in speed. If there is a decrease in speed, it means there is a deceleration. There is a decrease in speed. There will be negative acceleration or deceleration. Deceleration is increasing. If you can see that the graph in the beginning has lesser slope, lesser angle with x-axis, and with the passage of time, the angle with x-axis is not only negative, it is also increasing. So it means that deceleration is increasing in this case. This one. There is a decrease in speed. Deceleration is decreasing. As the gradient is decreasing, so there will be a decrease in acceleration. Now, negative velocity means object now moves in opposite direction than initial positive direction. So because we are dealing with a vector quantity here, so in this case, the negative does not mean less than zero. It means in the opposite direction. In vector quantities, -3 is not smaller than zero. -3 is not a compare, like it is like comparing 0 and 3. The difference is -3 is in the opposite direction as +3. So vector quantities with negative signs only mean that they are in the opposite direction. Like in this case, object now moves in the opposite direction. Velocity is increasing with constant negative acceleration. There's a constant negative acceleration and the velocity is increasing in the negative direction. So these kind of graphs can appear in front of you for velocity time, and you should be able to explain them. Let's have a composite graph. So here we go. This is a velocity axis. This is a time axis. Okay. Now, an object is moving on a straight line, in a straight line, on a level horizontal road, and we have mm, the graph. Just 1 second. Okay. Now, the first graph that I'm trying to make over here is the speed time graph, and we will be converting the same information into distance time graph and then into speed time graph. Oh, sorry, acceleration time graph. So this is speed in meter per second and time in second. So this is distance in meters, time in second, and this is acceleration in meter per second square and time in second. So we'll be making or converting the information of velocity time graph first into distance time graph and then into acceleration time graph. How many of you want to give it a try by yourself? Anyone? That we have already done this thing, distance time graph for increasing speed, constant speed, and decreasing speed should look like this. This is our previous lesson where we sketched these graphs. Now, numeric values are not required, but I can see in the middle part, there is a constant increase in the distance. So distance is increasing at a constant rate. Now, how the graph should look like in the first part. It should have an increasing gradient. Okay. It should have an increasing gradient in the beginning. And then at the end, the graph should have a decreasing gradient. And eventually it should become parallel to the x-axis because the speed has become 0. So this is how the graph should be for distance and time. Now for acceleration and time, I can see there is a positive constant acceleration for the first 2 blocks. And then for next 5 blocks, there is no acceleration. And then there is a negative acceleration, but I can see that the value of negative acceleration will be less than value of positive acceleration. So this is how I can convert same velocity time graph into distance time graph and then into acceleration time graph. We will be doing more of graphs in the next lesson. This is it for today. See you people tomorrow. Allah Hafiz.